Have you ever pondered the interplay between dimensions and life as we know it? Let's engage with a thought experiment proposed by renowned mathematician and science fiction writer Edwin A. Abbott. He introduced a two-dimensional world, inhabited by geometric figures, in his novel, Flatland, a romance of many dimensions. Imagine a creature residing in this two-dimensional universe, with only length and width to navigate, akin to a sketch on an unyielding plane. These beings exist in an entirely planar world, moving horizontally in any direction, yet the notions of verticality are non-existent. Now, juxtapose this with our vivid three-dimensional world, where an additional axis, height, enriches our perception. It empowers us to jump, ascend, and even soar. This additional dimension bestows us with the awareness of depth and distance, a perspective that would elude a two-dimensional being. Now, let's hypothesize. What if these disparate dimensions were to intersect? What if a two-dimensional creature were to find itself propelled into our three-dimensional realm? The experience would undoubtedly be as perplexing for it as it would be for us witnessing it. This hypothetical scenario can help us understand how dimensions shape our perception, a topic that has intrigued mathematicians and physicists for centuries. Now, shall we delve deep into this riveting concept? Imagine a creature that only has length and width but no height. What would happen if such a creature entered our three-dimensional world? To explore this, we'll delve into the first possibility, that this two-dimensional creature might become invisible upon entering our three-dimensional reality, and examine the scientific evidence that supports or contradicts this idea. To understand this, we need to grasp the basics of dimensions. To it simply, a dimension is a measure of spatial extent. In our world, we experience three dimensions: length, width, and height. This concept is supported by the theory of relativity developed by Albert Einstein. Now, let's consider a two-dimensional creature originating from a plane existence, which only experiences length and width. It has no concept of height. Should this flat being step into our three-dimensional world, it's a whole different ballgame. As this creature has zero height, our eyes, accustomed to perceiving three dimensions, might not be able to perceive it. It would be akin to trying to see a single sheet of paper from its edge. Practically impossible, right? Scientists studying human vision, such as cognitive psychologist James Cutting, have pointed out our visual perception is heavily influenced by three dimensions. From a scientific perspective, this phenomenon is connected to the way our visual perception works. Our eyes capture light reflected off objects, which then forms an image in our brains, allowing us to see. However, if an object has no height, it may not reflect light in the way we're accustomed to. Hence, our brains might fail to register its presence. This idea is supported in the physics of light reflection and absorption, a cornerstone of optics. Nevertheless, it's important to note this two-dimensional creature isn't truly invisible. It merely appears so because we are unable to perceive it. It's a bit like radio waves. Just because we can't see them doesn't mean they're not there. They're simply beyond our visual spectrum, an idea validated by the electromagnetic spectrum theory. In essence, our two-dimensional visitor could become a phantom forever unseen in our three-dimensional world. But remember, this is just one possibility derived from theoretical physics, and there are other scenarios to explore. So stay tuned as we delve deeper into this fascinating thought experiment in the next scenes, armed with scientific evidence. In essence, our 2D visitor could become a phantom, forever unseen in our 3D world. Let's delve into an alternate scenario using scientific analysis. What if our hypothetical two-dimensional entity is visible, but only when viewed from a precise angle? Imagine a piece of paper resting flat on a desk. From a bird's eye view, you can appreciate its outline, its pigmentation, and even its text. But viewing it laterally, it virtually becomes transparent. This isn't magic, it's simply due to its insignificant thickness, making it practically imperceptible from that standpoint. In essence, it mirrors our two-dimensional creature's existence within a three-dimensional plane. Consider it akin to a mural painted on a flat panel. From the front, the entire image is discernible. The strokes, the hues, the intricacies, but if you rotate it sideways, it appears blank. The art hasn't dematerialized indeed. It's merely that your has shifted, rendering it unobservable from that specific angle. Now, extrapolate this principle to our two-dimensional creature. It exists within the parameters of length and width, but lacks depth. Hence, from a frontal view, it is observable. You can scrutinize its shape, its locomotion, possibly even its interactions with fellow two-dimensional entities. However, from a lateral perspective, it vanishes. Still present, yes, but eluding visibility due to the perspective. Here's where the concept intensifies. Suppose you're not observing head-on or laterally, but from a skewed viewpoint. The creature might seem warped, elongated, or compressed, contingent on your angle. This is the captivating interaction between dimensions and perspectives. This thought experiment compels us to challenge our cognizance of reality, doesn't it? It drives us to ponder how much of our perception is confined to our viewpoint and how much remains unaltered, independent of our observation. It also incites curiosity about the creature's sensory perception. Does it perceive reality like us, albeit differently? Does it sense the third dimension in some capacity, even though it doesn't inhabit it? Thus, our two-dimensional creature serves as a live optical illusion, materializing and dematerializing based on your line of sight. But what if our 2D creature didn't just vanish or partially appear? What if it entirely transformed? Let's consider this third possibility, an idea that's not only fascinating but also challenging to our understanding of physics. As we know, our world is governed by three spatial dimensions: length, width, and height. But imagine if our hypothetical 2D creature, used to a world of length and width but lacking height, was suddenly propelled into our 3D reality. It wouldn't just vanish or show up as a mere line. Instead, it undergoes a dramatic evolution, adopting a third dimension, height. Now, according to the laws of physics, such a transformation would be a radical alteration of its very essence, similar to us suddenly gaining the ability to perceive a fourth dimension. But let's dig deeper into this scenario. What would this mean for the creature itself? This new dimension would present a vast new world of possibilities. It could now move up and down, in addition to sideways. It could explore spaces that were previously inconceivable. From the perspective of physics, gaining a dimension would inevitably increase its mass. However, such a transformation would be an expansion into a whole new dimension rather than a mere inflation. But how would it cope with this sudden change? Would it be able to navigate its new world? Or would it be overwhelmed by the sudden influx of new sensations, experiences, and an increased mass? Would it retain its 2D recollections? Or would these be lost in the transition? These are questions we can only speculate about, but they make for a captivating thought experiment. According to the laws of physics, in this scenario, our 2D creature would undergo a complete metamorphosis, becoming something entirely new in our 3D world. So we've delved deep into three hypothetical scenarios of what could transpire if a 2D entity was to infiltrate our 3D realm. But what are the scientific implications of this thought experiment? It's a conundrum that triggers considerable cerebral. In the initial scenario, our planar partner would become undetectable, devoid of any height in a volumetric world. This implies an extraordinary concept that entities could coexist with us, yet remain unseen, simply because they function in dimensions that our senses cannot comprehend. According to the M theory, an extension of string theory, there could be up to 11 dimensions, and we are only capable of perceiving 4 of them. In the second hypothetical scenario, the 2D creature's visibility could fluctuate depending on our line of sight. This drives home the point of relativity and how our interpretation of reality can significantly transform based on our observational standpoint. Einstein's theory of relativity orbits around this concept, expanding our understanding of space and time. The final scenario anticipates a radical transformation of a bidimensional being into a tridimensional entity. This insinuates the enormous potential for unimaginable alteration when transiting between dimensions. These propositions not only challenge our comprehension of dimensions, but also incite us to scrutinize and investigate the fabric of our own reality. While the chances of us encountering a 2D organism may be remote, reflecting on these potential outcomes can indeed bestow a fresh perspective on our comprehension of the cosmos.